Hello, welcome back to another thrilling geometry video about circles. Today we are talking about properties of chords and secants. Okay, so the first thing we're talking about is in the same circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if you look at this example right over here on the right, BA is congruent to CD, therefore we can conclude that arc AB is congruent to arc CD, since we know that their corresponding chords are congruent. Now look at this image on the left here. We want to find the measure of arc FG. So we know that the radius of the first circle is congruent with the radius of the second one, since we see these double tick marks. So this chord is congruent to this chord, therefore the corresponding arcs are congruent. So if arc J to K is 80, that means that G to F is also 80. There's a lot of relationships in this section where it's just if you know two things are congruent, then you know another set of two things are also congruent. Here's our next part. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. Okay, so in this case, the diameter would be from S to Q, since that's the first chord, and it's bisecting, which means it cuts it in half, and it's perpendicular, so it meets at a right angle. So the conclusion is SQ is a diameter. The next theorem, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So here we know that EG is a diameter, and since it meets at a right angle, we know it would have to bisect. Which means that FH is congruent to DH. Okay. Next example here. So we're trying to find FB. FB is this chord right, or segment right here, I should say. We know that this is a diameter from G to A, and we know that it meets at a right angle. Therefore, it has to bisect the chord DB. So if this side's 10, the other side has to be 10 as well. So you could write 10 units, or you could just write 10 since we don't have a specific label. Next part, it says find arc measures. So here, first thing to note is we have two chords that are intersecting. So since B to D is going through the center and it meets at this right angle right here, that means that BD is a diameter. Since that's a diameter, we know that this chord right here and this chord right here are congruent to each other, or not chord, segment. Together they make a chord. That also means that this arc and this arc are congruent to each other. So what we can do, we're trying to find the arc measures of C to D, D to E, and then the whole thing from C to E. So what we're going to do to solve for x is we're just going to set these two equal to each other since they're congruent arcs. So 9x equals 80 minus x. Let's add x to both sides. We get 10x equals 80, divide by 10, and we get x equals 8. All right, now that's not our final answer. We need to plug that back in. So from C to D, if we plug in 8 in place of x, it becomes 9 times 8, which gives us 72 degrees. So the measure of CD is 72 degrees, which means the measure of DE, since they're congruent, is also 72 degrees. And if you plug in 8 in place of this x right here, 80 minus 8 would give us 72. And then together we just have to add them or double them. And 72 times 2 gives us 144 degrees for our final answer there. Okay. Next, in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Remember that equidistant is just the two words equal and distant together. So if you notice here, from E to G is the exact same distance as from E to F. So we can conclude that the chords A, B is congruent with C, D, since they're equidistant from the center. All right, next part, given PV is equal to PW, so that means that these two segments are congruent. They're equidistant from the center. QR is equal to 2x plus 6, so this chord here is 2x plus 6, and this chord ST is 3x minus 1. Now, since the two segments are equidistant from the center, that would mean that the chords are congruent to each other. So what we're going to do is set these two equal to each other. 2x plus 6 equals 3x minus 1. In this section, there's going to be a lot of setting equal to each other, which is nice because they're pretty easy to solve. So let's subtract 2x. We get 6 equals x minus 1. Add 1 to both sides. And we get x equals 7 as the value of x. That's not the final answer, though. We want to find QR. So to find QR, we just got to plug it back in. So I'm going to plug this in right here. So we get 2 times 7 plus 6. 14 plus 6 gives us our final answer. QR equals 20. And if we wanted to find ST, it would be the exact same answer. And if you plug in 7 right here for this x, 7 times 3 is 21. 21 minus 1 gives us 20 as well. Okay,